This is going to be, this is our second day of working with the geometry concepts. We're going to be working with angles. We're still going to be working with segments. But before we get into this, and I know a few of them are done already, what I'm going to do is I'm going to put up on here what I've got up on the boards within the classroom because, well, if somebody's not here today, they still should be able to get it if they want it. But basically what we're looking at again is, whenever we're dealing with angles and geometry concepts, where we're trying to use algebra to figure out either how big the angle is or what x is, we need some information. Okay? If a right angle is what I'm given, and that clue is always with the little square that's there in the corner, I'm going to set my things equal to 90 degrees. If it's a straight angle, or just a straight line, I set them equal to 180. Or if they're angles inside of a triangle, okay, not outside, I think it was perimeter, but inside, I just go ahead, add those like terms up and set them equal to 180. And we'll see all of these today on the problems that we're doing. So that's one of the parts. And then the other part, there's actually going to be a part on here I don't have on the board. I'll talk about that in a minute. But again, the geometry concepts I've got up to your left. Move this up a little bit. Because for some of you that are flying along, I want you to be able to get everything here. When we get to segments, the midpoint, I just set the two sides equal and solve it. So like for the example one I've got on here, bless you, if I had 2x and 8, I'd just set them equal to each other and figure out what x is. X would be 4. If they give me the length, which is something new we're going to be looking at today, like here, I have 3x and 2. I don't set them equal because they tell me how long the whole segment is. So I add them up and set them equal to the length of my segment. Then I solve that equation, figure out what x is going to be. So I can figure out what, in this case, AB would be. And then yesterday, the two that I didn't put up on the board, so if you're looking for the review ones down here, somewhere, those aren't up on the board. So I'll leave those up here for a moment, is bisector, which cuts an angle in half. Remember, we made little marks on those yesterday, so we're going to set those equal to each other. Then we can solve those. And then vertical angles, that are the ones across from each other, okay, not next to, but across, we set those equal and solve. So, I mean, that's 6, 7 different things that are going on here. I can understand how that can get a little kind of confusing. So that's why I wanted to give you an opportunity to jot this stuff down where, if you want to, like I said, I think the quiz is going to be Friday. It might be Thursday, but we'll see here. We'll see how things are going after tomorrow. And that's basically what we're going to be looking at on these. Okay, but that's the only things that we're going to have on these. So again, if you're like, right now, you're like, I don't know if I want to write this down or not, that's okay. This will still be online sometime if you wanted to check it there, or I'll have it up to the period even when we get done doing the examples together here in momentarily. Okay, so now we're back actually looking at the concepts that we're going to be talking about. And I've actually filled in some of the info for you already that I wanted to go through and explain, but I thought it might save us a little bit of time and let you watch rather than be writing all the time. So, here's how this works. Right angles, like I put up on the board over there, whenever you see the little square, that's going to be a right angle. It's going to equal 90 degrees. So anytime we get those, we're going to set them equal to 90. For example, I bump this up a little. If we look at number 2, we get an example of that. There's my little square, which means it equals 90. So whenever I get that, I take each of the pieces that are there, the 2x and the 50, put them together, add them together, and set them equal to the angle, which is 90 in this case. And then I just solve the equation. So again, I'd minus 50 from each side. That's where this is coming from. And then I'd divide by 2. Which gets me to the answer for x. But that's not the final answer, because to find my other angle is 2x. So I take this x value, and I plug it in where the x is at. 2 times 20 is 40. 50 plus 40 is 90. I'm feeling pretty good about things. Sometimes, yeah. Okay? Anytime I see a right angle, anytime I see one of these little squares in the corner, those always equal 90. Okay? Now, yesterday we did some where it had this straight line or this straight angle. And there were two angle parts here. Same idea, except they're going to add up to 180. So if I was looking for one like that that was an example, we flipped over and took a look at number 9, because that one's done for us. Okay, the straight angle equals 180. And you're like, okay, well, where's this 90 maybe coming from? I'm just combining like terms. I have one term of set x's, so 5x. 25 plus 65 is where the 90 is coming from. And then again, I just solved the two-step equation. Minus the 90 over. So 180 minus 90 is 90. And then divide by 5 is where the 18 comes from. And just like I did before, once I know what this x value is right here, to solve it, I just plug that in where the x goes. So instead of 5x plus 25, it's 5 times 18 plus 25, and that's where that answer comes from. And I can always make sure I'm right. If I add these two up, I should get 180. Okay? So that's how the straight angle ones work. And I believe the only other one on this sheet, as we flip back to the front for a minute, okay, is the sum of the measures of the angle of a triangle. Okay? Just when they're inside the triangle. If they're outside, that's something different. Okay? So the measures of the angles of a triangle on the inside are also 180. So again, flip back over. I know we're in flip-o-rama mode here. To number 14 on the back of this sheet, I know it's 180 degrees inside. So here I look and I say, okay, I have 1x here. I have another one here. That's 2. So that's where this comes from. I only have one plain old number, 40. So I add these up. 2x plus 40 equals the degrees inside, 180. And then again, it's a two-step equation. Minus the 40. So 180 minus 40 is 140. And divide by 2. I get 70. And since angles S and T are both just x, they're both 70. Because then 70 plus 70 plus 40 is 180. And I'm good to go. I'm done. I'm finished. So you start to see, okay, the process is pretty much the same once I get the equation set, but I get the equation. And that's why we've got the help that we're trying to get to beyond notes. As far as the segments go, when we do these, let's say we've got one like number 2. They tell me how long the whole thing is. The whole thing is 13. I know this part's 9 and this part's x. So to find it, I add the two parts together and set it equal to the whole. And then I just go, oh, I'm going to minus 9 to be able to figure this out. And I figure out what x is going to be. Or I get down to here and I say, okay, let's say I'm doing 4 instead. So here, I know it equals 19. I have like terms I can put together. I have 2n and 4n and 6n minus 5. And then I just solve the equation from there. I add the 5 over. And I divide by 6. So that gets the n. But then to find the two parts, I have to plug it in. So it says RF. Here's RF. It's 2n. So it's 2 times my new n value. So 2 times 4 is 8. Or SV is 4n minus 5. 4 times my n is 4 minus 5. 16. 4 times 4 is 16 minus 5 is 11. And I'm done. And the only other type that we're really dealing with here on these is midpoint. But we did midpoint yesterday. Midpoint is just equal. Okay? So if they don't give me how long the whole thing is, When they give me the length of the whole thing, I add them up. But if they give me midpoint, I just set them equal to each other. And then I add my 12 to the other side. And I divide by 6. And get my x value. And then AB is 6 times x, but I know what x is now. X is 8. Minus 12. 6 times 8 is 48. Minus 12 is 36. Now I already know this part's 36, so I just figured out this is 36. I know this part's 36. So to find the whole thing, I just add those two together. So we get an idea of midpoint, or if I just have segment lengths that I'm working with, how that's going to work. And I think the one last thing on here that's going to be on the very back is like what we were doing yesterday. But I'll still do a couple just to make sure that we're on the right track with things. Okay? So I believe that our last one here in a minute is going to be working with perimeter. I wanted to make sure we talked a little bit about perimeter because, again, lots of different concepts going on here. We kind of have to keep working on keeping them straight with each other. Sometimes that's a little easier said than done. And I'll wait a second here because I see a couple of you jotting down still, and then we will flip over. Yes, ma'am. That one, they put measurements on them. So like when it says 7M or 10M or something like that, just look at them like they're plain old numbers. That's actually the next one I'm going to do. All right, let's flip over there and see what's happening. Okay. I wish I wouldn't have done this. I put labels on these, and I think that's causing the problem here on the back. These M's, I don't want you to think of them as variables. The only place you should see a variable is on the X on that one. So like if this one we're doing perimeter, remember, just add up all the sides. So here, I'm like, okay, I only have one term that has X, so I'm going to write my 2X. Now that we're rid of the M dilemma here, 7 and 10 is 17. And that's going to equal 25. And then, just like always, we're solving for X. So we're going to minus the 17 over. And we're going to divide by 2. But again, once I have X, that's not everything. To find BC, that's 2X. So it's 2 times 4, which is going to be 8. And the last one I think we're going to take a peek at here is number 2, right next to it. Now you're like, how can I find the perimeter? They didn't give me all the sides. But actually they did. What do we know about the opposite sides of a rectangle? They're the same. So if this is 10, this is 10. If this is X, this is X. Okay, so we've got 2X. X plus X is 2X. And if I've got 10 here and 10 more here, that's 20. And they tell me what the perimeter is. So I add up the parts they've given me around the outside, and I set them equal. Then again, I'm working on getting 2X by itself. So I'll minus the 20 over, and then just divide by 2. And all I was asked for this time is to find X. I'm good with that. So I'll just find X and be done, because that's going to be my width on each of those. So your job, both today for the last half of class, okay, and moving forward, is, if you're still working on some from yesterday's, please finish those up. Otherwise, we're going to work on knocking this part out. And like I said, today and probably tomorrow we'll be doing some more with these just to kind of get a feel for it. And Thursday or Friday there's going to be a quiz. But there will be a quiz preview before it. So if you see the quiz preview tomorrow, we're probably quizzing on Thursday. If you see the quiz preview on Thursday, well then I guess that's Friday then. But again, any issues?